Scripting offers us a ton of flexibility, and in this video I'm going to talk about a specific implementation of scripting in GeoGebra. So consider the following example. Suppose we have 2 points, A and B, and we want A and B to be related in a specific way. In particular, we want it so that A, anytime we move A, B is always 1 unit to the right and 1 unit up from A. And then if we move B, A is 1 unit to the left and 1 unit down from B. So we want A and B to be related in that way. And so your first thought might be, all right, let's delete B, and maybe we define B to be A plus 1 comma 1. So we'll take the point A, and we'll add 1 to the X and add 1 to the Y, and we'll give that a shot. Now if we drag A, we get what we want. B stays related to A in the way that we want, but B is a dependent point, so we can't drag B. If you try to drag B, it just won't work. So we've got one way working, but the other way doesn't work. So I'm going to delete both of these points. We'll use the point tool and real quickly put them back so that both of these points are free to move. And what we'll do is use scripting to handle this situation. So I'm going to right click on A, go to the object properties, and open the scripting tab. When A is updated, we want to do something. We want to set the coordinates of the point B so that the x-coordinate of B is the x-coordinate of A, but plus 1. And we want the y-coordinate of B to be the y-coordinate of A, but plus 1. And recall that the setCoords function takes an object as its input, its first input, and then the second input tells us the x-coordinate to change that point to, and then the y-coordinate that we want that point to have. So I'm going to close out of this, and let's drag A. And it looks like it's doing what we want it to do. As we move A, B stays 1 unit to the right and 1 unit up. But now if I drag B, nothing happens to A. So we need to go into B's scripting, and it's on update scripting, and we'll set the coordinates of A so that the x-coordinate of A is x of B minus 1, and the y-coordinate of A is y of B minus 1. So this is saying that whenever B is updated, we're going to set the coordinates of A so that the x-coordinate of A is x of B minus 1, and the y-coordinate of A is y of B minus 1. So we'll close out of that. Now again, dragging A works. And now as we drag B, A is updating accordingly. So now we have codependence between these 2 points. And this is very nice. All right, let's look at one more example that's similar to this. We'll define f to be f of x equals e to the sine of x, my favorite function. And what we'll do is place 2 points, 1 point on the graph of f and 1 point on the x-axis. So first of all, we'll do p sub 1 equals, let's make this a point on the x-axis. And p sub 2 will be a point on the graph of f. So now we can drag p1 along the x-axis, p2 along the function graph. And what we want to do is anytime we drag p1, p2 updates accordingly, and vice versa. So in p1's on update script, we're going to set the coordinates of p2, and we want this coordinate to be, the x-coordinate to be the x-coordinate of p1, but then the y-coordinate should be f of x of p1. Now, let's try this out. So let's go ahead and close out of that. And as we drag P1, P2 updates accordingly. But the other way is not true. So let's go ahead and enter P2's object properties. Scripting tab. As we update P2, let's set the coordinates of P1 so that the x-coordinate is x of P2, and then the y-coordinate is just 0. Okay, so now as we drag P2, P1 updates accordingly, and vice versa.